All right, hey. Got a little geometry here for you today. We're going to look at section 6.6. This section is all about various theorems that have to pertain to proportional parts. So it's kind of some random thoughts, I guess you might say. They don't really necessarily all fit together. They're just a couple of just different theorems that if you have certain scenarios, you can write some proportions with. The first one, theorem 6.4, says that if a line is parallel to one side of a triangle, then it separates the other two sides into proportional parts. And you might recognize this theorem, in particular when you see the picture, as one of the questions on your mid-chapter quiz the other day. Alright, so here is some added information that you didn't have to know this when you took the quiz, but knowing this, maybe it would have made it easier to solve for one of the two variables. So maybe if you see a picture like that again on the chapter test coming up, you'll be able to solve it better. So here's your picture. Notice right now you got two parallel lines. This is the picture that we had on the quiz, and now you have these parts here. And the thing I like about these theorems is I think you can see the fractions. Like when I look at this right now, I see 6 over x. That parallel line is kind of like almost like a fraction bar, and I see 4 over 3. And so for me, it's really easy to see those two fractions and then to cross multiply and work that out. All right, so you could have used that idea, to solve for those variables on your quiz the other day. Okay, you didn't have to. You could still use similar triangles. There's still similar triangles in this picture. All right, you could match up 6 to the whole entire length, 6 plus x, and you could match up 4 to the whole entire length of 7. But I think that the one we wrote earlier is a lot easier. Okay? All right, so now that you've seen this, I'd like you to practice it once. So I'll draw a picture for you. I'll give you some information. I'd like you to push pause on the video and either working by yourself or working with a partner right now, work on trying to solve this problem for the two variables right now. I'm going to give you an x and a y in this problem. So again, here's your two parallel lines, and now here are your various pieces of information now. Once you have this copied down, I'd like you to push pause and solve for x and y. Alright, so you're going to solve for x and y, and you can push pause at any time. Alright, so hopefully this is the proportion you started with. X over 25 equals 8 over 20. Remember, those are the fractions that I see right away. I see them right on top of each other there, the x and the 25 and the 8 and the 20. Alright, cross multiply, solve that, you get x equals 10. Now, here's where the problem gets tricky. When people do this, they want to write something like x over 25 equals 40 over y, or something like that. You can't do that. The 40 and the y don't have anything to do with that theorem anymore. So now you must use the similar triangles. Alright, so 25 represents the length of the little triangle. 35 represents the length of the big triangle because we added that 10 in. Alright, then you have that equals y over 40. Cross multiply, divide. Y is now going to be approximately, this if you round it, about 28.6 or so. This is the part that people really mess up. So make sure you understand what I did here. If you need to go back and look at that again and see where those numbers come from, make sure you do. Second theorem we're going to look at tonight, theorem 6.6. This one says that if you have 3, or for that matter 3 or more parallel lines, and they intersect two transversals, then all of the little parts that are created by these lines are going to be proportional. That might be a little hard to understand at first. After you see a picture of it, I think again it'll make sense. And again, just look and see the fractions that are formed. Again, for me, I think the fractions, the ratios, really stand out. The parallel lines act as fraction bars. So here's my parallel lines, and I've got some transversals. And hopefully you're already seeing where your fractions could be. And so you have that little length in there is 4, and that little length in there is x. That little length over there is x plus 1, and that one right there is 6. So for me, right now, I'm going to emphasize it to you, but to me, it seems really easy to see 4 over x and 6 over x plus 1. Those are your fractions. Those are the ratios that you're going to set equal to each other. So we do that, cross multiply again. Make sure you distribute your 4 through like you're supposed to. And when you solve that, you get x equals 2. Now that you've seen me do it once, again, I'm going to give you a practice problem to work on now. Okay? So copy this picture down, put the information in. Again, you're looking for parallel lines first. So there's your parallel lines. Here's your transversals. Now I'm going to give you some information here. Once you have it copied down, pause the video, work on finding the solution here. And that's supposed to be a 5 right there. So go ahead and pause it now. Hopefully again you saw those fractions there. Hopefully they stood out to you. Now here it's going to be a little bit trickier because you've got a quadratic going on. You got an x squared in the problem. So you got to get everything over on one side. Set it equal to 0. I don't believe that you can do any foiling on this or unfoiling. So we're going to put in quadratic formula or quadratic equation. Opposite of b plus or minus b squared minus 4 times a times c all over 2a. Go through the work of simplifying that problem. Square root of 61 to 1 decimal place is right about 7.8 or so. Two solutions here. Negative 1 plus 7.8 divided by 2. It's going to be a positive 3.4. I'll correct that mistake here in a second. And then negative 1 minus 7.8 divided by 2 is a negative 4.4. Obviously can't have a negative length in this problem, which is what x would be, so we throw that out, and our one solution is 3.4. Again, see the fractions. Last theorem we're going to look at, theorem 6-7. This one's a little bit confusing until you see a picture of it. It says an angle bisector divides the opposite side, so your angle bisector is going to be drawn to the opposite side, and it divides the opposite side into parts that are proportional to the other two sides of the triangle. So again, I'll show you a picture here. So you have a triangle. You must have an angle bisector drawn in. So you got to make sure that that's going on. Alright, it has to be an angle bisector. And then once you have that angle bisector drawn in, the parts on the opposite side now are going to be proportional to the other two sides of the triangle. Now again, you're going to have numbers that are written on top of each other. Just write the fractions that you see. So what's your first impression? When you look at these four variables, numbers, everything here, what do you see? That's what I see. I see 6 over 4, 8 over x. That's a legal proportion to write. Cross multiply, 6x equals 32. Divide by 6, you get x equals 5 1/3. Okay, pretty straightforward. Alright, here's your example problem now. It's going to be a little bit different. See if you can use some good critical thinking skills here and think through how you can solve this. Again, it's going to be just a little bit different than the problem I just gave. Again, after you see that information, please take a moment, push pause, try to work through it first. If you choose not to do that, that's your decision, but you need that practice for the test coming up. Push pause now. So, big thing is, what are you going to call that piece right there? I say it's 20 minus x. Whatever the other piece is, you can figure out what that length is by subtracting from 20. Once you have that, pretty easy to see the proportion. Pretty easy to see the ratios, the fractions that you're going to write, the numbers that are right on top of each other. You could even write it 11 over 14 equals 20 minus x over x. However you write it, do your cross multiplying, get all your x's on one side, divide by 25, and in this case, you got an answer of 11.2. Hope these three theorems make sense. Right, again, go through them as many times as you need to. Listen to my explanation, see the examples. But again, take the time right now to get some practice on these. That's the only way you're going to get more comfortable with them. So your homework assignment is on page 400. You can do problems 3 through 17.